Let f of x equal x cubed minus 3x squared plus 1 when x is an element of the real number set. Part 1. Write down f prime x, the derivative of f of x. Part 2. Hence, find the range of values of x for which f of x is increasing. So when we're differentiating, the rule is we bring the power down in front and we reduce the power by 1. So if I bring down the 3 in front of this x, I'm going to get 3x. And if I reduce the power by 1, 3 take away 1 leaves me with 2. So the derivative of x cubed is going to be 3x squared. With minus 3x to the power 2, if I bring down the 2 in front, it becomes minus 3 multiplied by 2, which gives me minus 6. And then 2 take away 1 will be 1, leaving me with x to the power 1, which is just x, so I get minus 6x. Then I have plus 1, which is a constant. I cannot differentiate that, so I just cancel it out. So if the function is x cubed minus 3x squared plus 1, then the derivative of that is going to be 3x squared minus 6x. So here is a graph of my function x cubed minus 3x squared plus 1. And we can see that it is an S-shaped graph. And we're interested in seeing where it is increasing. Well, we read a graph just like we read a book from left to right. And if we're going from left to right, we can see that the graph is increasing, so it's going upwards, it's going uphill, right until we get to x is equal to 0. At that point it levels off, and we would have a slope of 0. Then we can see that the graph starts to decrease, it starts to go downhill because we're reading the graph from left to right. And then again it's going to level off at x equals 2, so there would be no slope at this point. And then it starts to increase again, and it continues upwards to infinity. So we're interested in where it's increasing. So it's increasing up until it reaches this point, which is x is equal to 0. And then it is increasing from this point, where x is equal to 2, and it continues increasing. So we can say the graph f of x is increasing when x is less than 0. So we can see that this is the point on the graph where x is 0. So everything before that, we can see the graph is increasing. And also when x is greater than 2, we can see that the graph is increasing for every value of x greater than 2. But what if we are not given the graph, and what if we cannot see it from the graph? There needs to be another way that we can work this out. So f of x increases when its derivative is greater than 0. And likewise, a function would decrease if its derivative is less than 0. But in this case, we're interested in when our function is increasing. So our function increases when its derivative is greater than 0. So obviously we are going to use the derivative to help us with this question. And we found in part 1 that the derivative was 3x squared minus 6x. Now 3x squared minus 6x, if I was to draw this out, is going to give me a U-shaped graph. For the moment, it doesn't really matter where the graph is, it just matters that it's a U-shaped graph. If this was a negative x squared, it would be an N-shaped graph. But it's a positive x squared, so it's a U-shaped graph. Now we're interested in finding the roots of our graph, so the points at which it crosses the x-axis. And in order to find the roots of a quadratic, we need to solve it. If I want to solve this quadratic, the first thing I'm going to do is I'm going to factorize it. I'm going to take out the highest common factor from 3x squared and minus 6x, which is going to be 3x. So 3x divides into 3x squared and leaves me with x, and 3x divides into minus 6x and leaves me with minus 2. I can check on my right by multiplying out the brackets. 3x by x is 3x squared, 3x by minus 2 is minus 6x. So now I need to solve. What I'm going to do is let the 3x equal 0, and then I'm going to let the x minus 2 equal 0. So 3x is equal to 0, so x is going to be equal to 0 divided by 3, so x is going to be equal to 0. So that's where that part comes from there. X is equal to 0. Okay, and then likewise, I'm going to let x minus 2 equal 0. So x minus 2 is equal to 0, so x is going to be equal to positive 2. So that's where that comes from there. So now I know the roots of my equation are going to be x equals 0 and x equals 2. These are also known as the x-intercepts. So the points at which my graph crosses the x-axis, the x-intercept. So I can draw them in now on my U-shaped graph, the point 0, 0, and the point 2, 0. So it's going to be the x value of 0, and obviously 0 for the y value, because it's along the x-axis, and then an x value of 2, and a y value of 0, again, because it's along the y-axis. So these are the 2 points at which my graph crosses the x-axis. And I know that my function will increase when the derivative is greater than 0. So this is another way of saying when y is greater than 0. So when my y values are greater than 0. And my y values are greater than 0 for any of these points. So 0, 1, 2, 3, 4, 5 into infinity. Anything below the x-axis or below y is 0 will tell me where my function is decreasing. But at the moment I'm interested in where my function is increasing. So I know that it's going to be any point at which is above my x-axis. So along these points here and along these points here, my graph is increasing. So reading from the graph, we can see that the derivative is greater than 0 when x is less than 0, which is here, so anything to the left of it, and x is greater than 2, which is here, so anything to the right of it. Therefore, f of x, my function, is increasing when x is less than 0 and x is greater than 2. And if we go back to our actual function, our cubic function, our S-shaped function, we can clearly see that our function is increasing when x is less than 0, which is going to be right here, and when x is greater than 2, which is going to be right here. So our graph is increasing up as far as x is equal to 0, then it starts to decrease, and then it is increasing again at x is equal to 2. So our function is increasing when x is less than 0 and x is greater than 2.